Namaste, kya haal hai? Welcome to day 6 of our machine learning journey. I am absolutely pumped today because we are decoding the true king of ML algorithms. If you've been following Kaggle competitions, tracking top startups, or looking at massive enterprise systems, you'll know random forest is literally everywhere. So today, we're going totally hands-on to see exactly how it ticks. Get ready because we are about to build some serious data science muscle.
But hey, before we start celebrating random forest, I've got a massive shocker for you. Literally everyone in the industry will tell you random forest is invincible. It's supposed to be this ultimate powerhouse, right? But in today's project, Logistic Regression completely destroyed random forest. I know, no way, right? How is that even possible? Well, stick with me because by the end of this explainer, you're going to finally understand why your algorithm choice 100% depends on your data.
All right, let's get into the core philosophy here. There's this famous saying in our community, एक tree गलत हो सकता है, पर 500 trees 7 गलत नहीं हो सकते. Exactly. One tree can definitely make a mistake, but 500 trees voting together, they just can't be wrong. This is the absolute foundation of why random forest is usually such a beast. It completely relies on the wisdom of the crowd.
So, let's play a little game. The 20 questions game to be exact, which is the perfect way to understand decision trees.
Because to really understand a whole forest, we first have to understand a single tree. It's exactly like that guessing game you played as a kid. Let's say I've got an animal in my head. You ask, step 1, does it have 4 legs? I say yes. Step 2, does it bark? Yes again. Boom! Step 3, it's a dog. This is beautifully simple, but it perfectly illustrates how a single decision tree works. It just takes your massive data set and splits it, question by question, branch by branch, until it lands on a confident answer.
But here's the catch. Using just one decision tree leads to a massive problem called overfitting. Think of it like a student who completely memorizes the exact exam questions the night before a test. I mean, sure, they might score 100% on those specific questions, but put them out in the real world, they totally fail because they didn't actually understand the core concepts. A single decision tree basically just memorizes the noise in your training data, making it super weak when it faces new real-world data.
Which brings us to the ultimate solution, the wisdom of the crowd. Enter the random forest.
Think about it. If one student memorizing is a disaster, what if we grab a whole classroom of students who studied completely different chapters of the textbook and we let them vote on the final answer? That is the magic right there. And that number, 500, in Python code, that's your crucial hyperparameter called n_estimators. The real strength of this algorithm comes from ditching that one weak overfitting tree and instead creating 500 different trees that vote together to find the truth.
So how do we actually make sure these 500 trees are different from each other? We use 3 beautifully simple steps. First, bootstrap sampling. This just means we give each tree a slightly different, random slice of the training data. Second, random feature selection. We only let them look at a random subset of the clues. And finally, majority voting. We literally just ask all 500 trees for their prediction, and whatever the majority says wins. It's so simple, but mathematically, it's a total game changer.
All right, but let's talk about the elephant in the room. When random forest fails. This is honestly the biggest lesson of our session today.
Let's bring it back to that dramatic reality I mentioned earlier. Random forest actually lost to logistic regression today. I really want to trigger a senior thinking moment for you right now. Why exactly did the algorithm choice depend so heavily on the data? Why didn't our 500-tree powerhouse just crush it?
Here's the technical breakdown. First up, our specific dataset today had a strictly linear shape. Logistic regression is literally designed to draw a straight line through linear data, while trees awkwardly try to create these boxy, step-like boundaries. Secondly, our dataset was pretty small. And third, the default probability threshold of 0.5 is absolutely terrible for imbalanced data. If you don't tune that threshold, random forest is going to fail. It proves that your algorithm absolutely must match the shape and size of your specific data. Now, does that mean we just throw random forest away? No way! Let's talk about its feature, importance, superpower. It is literally a hidden gold mine.
Even when it loses on raw accuracy, random forest has this absolute superpower. Look at this breakdown from our model's output today. It mathematically proves that the RFM_score feature alone carries nearly 30% of the predictive weight in our data. That is pure, actionable business insight. You can literally walk into a CEO's office and say, hey, focus all your marketing on improving the RFM score, because it controls 30% of customer behavior. Logistic regression really struggles to give you that kind of clear, nonlinear ranking.
And this is exactly why it's so popular out in the industry. Let's look at some real-world ML applications and how massive enterprises use random forest.
I want you to feel a massive sense of achievement right now, because you're learning the exact same mathematics that giants like Mastercard use for credit card fraud detection. They literally use this wisdom of the crowd to spot a fake transaction in milliseconds. And Apollo hospitals? They use random forest for complex disease prediction. Looking at hundreds of patient symptoms, like a giant 20 questions game, can literally save lives. You guys are building real enterprise-grade ML intuition here.
Before we wrap up, let's do a rapid-fire value dump. Here are the most common beginner mistakes and exactly how to fix them like a pro. Mistake 1. Thinking random forest always wins. Fix. Always compare algorithms based on your data. Mistake 2. Scaling features for random forest. Fix. Trees don't care about distance, so they literally don't need scaling. Mistake 3. Using a tiny n estimators like 10. Fix. You need a real crowd, so use 200 to 500. And finally, ignoring the OOB score. Fix. Always set OOB score to true. It gives you free, built-in validation. So, you've officially mastered the forest, but our journey is far from over. Are you ready for day 7? Because we are finally going to tackle XGBoost, the true undisputed Kaggle king. To unlock the next incredible session, drop your answers to today's 3 challenge questions in the comments below. 6 days, 6 algorithms, and real business insights. You're doing absolutely amazing. I'll see you in the next explainer. Keep going strong.